Now we're going to do question 1 of this prelim paper. In question 1.1, we are asked to solve for x. So 1.1.1, we are asked to solve for x for this problem here. So the first thing we're going to do is we're going to factorize this problem here. So we're going to find the factors of x squared, which is x and x, and the factors of 27 such that they give us the middle term. So it's going to be 9 and 3, right? 9 times 3 is 27. So the bigger number takes the sign of the middle term, which is negative, and this will be positive. So it's equals to 0. So after finding the factors, we're just going to equate our factors to 0. So it's x plus 3 is equals to 0, or x minus 9 is equals to 0. And then we transpose the 3 to the other side and the 9 to the other side. We have x equals to minus 3. Or x is equals to 9. So these are our solutions of x for this problem. Now 1.1.2, we are asked to solve for x for this problem here, and our solution must be correct to 2 decimal places. So since we are told that they must be in 2 decimal places, we know we have to use quadratic formula, meaning that we cannot factorize this problem here. So the quadratic formula is x equals to minus b plus or minus root of b squared minus 4ac all over 2a, right? So, but we first need to write this 2 plus x into standard form, right? Equals to 4x squared. So we're going to transpose the 4x squared to the other side. We have minus 4x squared plus x plus 2 equals to 0. And then if we divide by negative 1, both sides will remain with 4x squared minus x minus 2 equals to 0. So this is our standard form of the equation. So we're going to substitute it in this quadratic formula, which will be minus into our b, it's minus 1, plus or minus root of our b is minus 1 squared minus 4, our a is 4, our c is minus 2, divided by 2, our a is 4. So the solutions of x that you're supposed to get, it's x is equals to minus 0.59, or x is equals to 0.84. So these are the solutions of x that you need to get for this problem here. So now we're going to do 1.1.3, right? So we're going to solve for x for this problem here. So we're having the root of x minus 2 all squared is equals to 1, right? We can solve it many ways. We can expand this expression here and find the product, or we can simply use the square root. So let me just use the simpler method, which is to just put the square root. So we're just going to put the square root here and here, and then we will have root of x minus 2 is equals to plus or minus 1. That is the solution of the square root of 1, right? And then we'll transpose the minus 2 to the other side. So we have the root of x is equals to plus 2 plus or minus 1, right? And then solutions of x would be the root of x is equals to 2 plus 1, or the root of x is equals to 2 minus 1. And if you add these, you're going to have root of x being equals to 3, or root of x being equals to 1, right? And then because we want the solutions of x, we're going to square both sides. Even here, we're going to square. And then here the solution of x will be equals to 9, and here or x would be equals to 1. So these are the solutions of x. Now we're going to do 1.1.4. So we're having this problem here, and we're asked to solve for x. Please note that there's an equality sign here. So we're going to have x squared plus x minus 6 greater or equals to 0. First step is to factorize. So we're going to factorize and find factors of x squared, which is x and x. Find factors of 6 such that they give you the middle term. So it's going to be 3 and 2, right? The bigger number takes the sign of the middle term, and here it's going to be negative. So your critical values is going to be x equals to 2 or x is equals to minus 3, right? So these are your critical values, not your solutions of x. So what you're going to do is you're going to draw your number line and present your critical values. So you have your critical value of minus 3 and your critical value of 2. So let me write critical value, critical value. So what you're going to do is this: you're going to test values before your critical value, in between your critical value, and after your critical values, right? So you can choose any numbers. Let's say, for example, for this case, you're going to choose -4 because it's below -3, and you can choose here 1. So these are your numbers that you can test in your equation, or you can choose 1 here, which is after the critical values. So what you're going to do is you're going to substitute these values in this equation here, right? For example, you're going to say x is equals to -4, and then you substitute it in this equation here and see the solution that you're going to find. What's mostly important is the sign of the solution, right? We want to know the sign, not necessarily the number, right? So when you substitute this value, x equals to -4, you're going to get a solution that is positive, right? So it means now that numbers below this critical value of -3 is actually positive. So the solutions of y are positive just below -3, right? And then you're going to test this value of 1 here and substitute it in this equation here, right? And you'll find that the solution will be negative, meaning that values between -3 of the critical value and 2 will give you solutions of y that are negative, right? And then you're going to do the same thing. You're going to test this value here of 1, and you will find that the solution is positive. So the solutions of y are positive. So how do you know that you need to substitute these values, or how can you conclude now that we found the solutions of y that are either before or after our critical value? How do we find or conclude the solution of x? So we're going to look at this inequality sign here. So sorry about that. So we're going to look at the inequality sign. So the inequality sign says that we want solutions of x such that the solutions of y are greater or equals to 0, right? So what that means is we want the solutions of y to be positive, right? So what are the values of x when solutions of y are positive, right? So where are solutions of y positive? They are positive here and they're positive here, right? So meaning that your x values in this point here will face the positive side. Even here, they will face the positive side. So your x values will face the positive side, right? So how we conclude, we're going to say when x must be less than or equals to -3. So when x is less than or equals to -3, it gives you positive solutions of y, right? Or x must be greater or equals to 2. So when x is greater or equals to 2, it gives you positive solutions of y. So now we're going to solve 1.2, where we are asked to solve for x and y simultaneously using the following equation. So we have this equation and we have that equation. So our equation 1 can be 4x plus 2. Label it equation 1. Equation 2 can be 2 plus x, x plus 1 equals to y plus 12, right? It can be equation 2. So if we check, we can simply substitute this equation 1 here where there's y, right? Sorry about that. So you can substitute this equation here, just here. So you can simply write 2 plus x and x plus 1 is equals to, so where we see y, we're going to put 4x plus 2. So it's going to be 4x plus 2 plus 12, right? And then we'll have 2 plus x, x plus 1 equals 2. So if you add these, we're going to have 4x plus 14, right? And then here we're going to find the product using FOIL method. We'll have 2x here, and then these 2 multiplied by the 1, we have plus 2, and the x multiplied by the x is x squared, and the x multiplied by 1 it's plus x equals to 4x plus 14, right? and then we add like terms, so it's going to be x squared plus 3x plus 2 is equals to 4x plus 14, right? And then you transpose everything this side to the other side, we have x squared plus 3x minus 4x plus 2 minus 14 equals to 0, right? So it's going to be x squared minus x, which going to add these two, so it's going to be minus x, and then these two here is going to be minus 12 is equals to 0. And then we factorize this problem here, equate to 0. So the factors of x squared, it's x and x. The factors of 12 such that they give us the middle term, we can use 4 and 3, right? And the bigger number takes the sign of the middle term, which is negative, and here it's going to be positive. So x should be equals to minus 3, or x should be equals to 4. So these are the solutions of x, and then we will use this equation here to find the solutions of y. So when x is equals to minus 3, what is the solution of y? It's going to be y is equals to 4 into minus 3 plus 2, so it's equals to minus 12 plus 2, which is equals to minus 10. So the solution of y is minus 10. The second solution of y, so let me erase here. So the second solution of y is going to be when x is equals to 4, right? This is another x value which we found here. The y is going to be equals to 4 into 4 plus 2, right? So which is 16 plus 2, which is equals to 18. So the solution of y is 18. So now we're going to do 1.3, where we are given this factorial of 10 being equals to the factorial of a, factorial of b, and factorial of c, where a is not equals, where a is not equals to 0, b is not equals to 0, c is not equals to 0, right? Determine the possible values of a, b, and c. So we have 10 factorial, right, which can be written as 9. So we have 10 factorial, right, which is equals to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's how you present this factorial, right? So what we can do here, it's all about manipulating, right, to make sure that we have 3 factorials at the end. So what I'm going to do is this. I'm going to break down this 10, 9, and 8, right? It's possible to break them down, but it's not possible to break down this 7, right? So hence I'm just going to break down these 10, 9, and 8, just to simplify it further. So to get 10, you have to say 5 times 2, right? And then to get 9, you have to say 3 times 3, and to get 8, you have to say 4 times 2, right? And then you multiply the 7, this part here, times 6 times 5 times 4 times 3 times 2 times 1, right? So what I'm going to do, I'm going to group everything. This 7 times 6 times 5 times 4 times 3 times 1 is going to be 7 factorial, right? And then this 5 and 4 and 3 and 2 will be 5 factorial. It's going to be 5 factorial, this part here, except this one here, because we already have 3. So it's just going to be this 5, these 2, these 3, and this 4. So we remain with this 3 here and this 2 here, which both of them, they can be 3 factorial, because 3 times 2 and then times 1. So we now have factorial of 3, factorial of 5, and factorial of 7, right? So we can simply say factorial of 5 multiplied by factorial of 3 multiplied by factorial of 7. So this presents the value of a factorial, this presents the value of b factorial, and this presents the value of c factorial. So we are done solving this problem here. Now we're going to do question 2. 2.1, we are given the following sequence. We are not told what type of sequence this is, whether it's arithmetic or geometric. But in 2.1.1 we are asked to write the next term of the sequence, right? So what we can detect, you can first try and finding the difference of these sequence and see if you will get a common number, but it definitely won't. So what I can notice from this sequence is, if you have 9, how do you find 9? 9 is 3 to the power of 2, right? Or express 9 in terms of 3. Let me just say that. It's 3 to the power of 2. And how do you express 27? It's 3 to the power of 3. Express this 81, it's 3 to the power of 4. Express this one here, it's 3 to the power of 5, right? So if you can see here, we're having an exponential form of 3. So it's 3 to the power of 2 to the power of 3, 3 to the power of 4, 3 to the power of 5. This gives me a hint that this might just be a geometric sequence, right? So for us to prove that, because we firstly don't need to prove it, we just need to write the following term, right? So basically what's common here, what's common is 3, right? 3 is common, so basically it's 3. Maybe you just need to note the power. If you check, it's to the power of 5 here, it's to the power of 4 here, it's to the power of 3, to the power of 2. Definitely yes, it has to be to the power of 1. So this is our next term for 2.1.1. It is 3 to the power of 1, right? And then looking at 2.1.2, they say, does the series converge? Okay, so we know very well that convergence only happens in geometric sequence, right? What do I mean by that? We have an equation that says R must lie between 1 and negative 1. So this equation here, it actually explains the convergence of a sequence. So if and only if R lies between minus 1 and 1. So let's first find R, then we'll conclude on whether or not the series converges. So R is equals to term 2 over term 1 is equals to term 3 over term 2. So what is term 2? This is term 2, this is term 1. So term 2 is 81 divided by term 1, which is 243, equals to term number 3 is 27 divided by 81, which is term number 2, right? So you should find R to be 1 over 3 if you punch your calculator. So this is the value of R. I mean, this 1 over 3 is 0.333, which definitely tells us that it lies between minus 1 and 1. So you can conclude by saying 1 over 3 lies between negative 1 and 1. So this can be your final solution of this problem here. We're going to do 2.1.3. We are asked to prove that the general term of the sequence is equals to this here, right? So let's find the general term of the sequence. So how do you find the general term of a geometric sequence? We know it's Tn is equals to AR to the power n minus 1, right? Our A value is our first term, which is 243. It's this one here. And then our R, we calculated it in the previous question to be 1 over 3. So we're just going to substitute that. Tn is equals to 243 into 1 over 3 to the power of n minus 1. Remember about the 243. In the previous question, the 2.1.1, I said this is 3 to the power of 2, this is 3 to the power of 3, this is 3 to the power of 4, and this is 3 to the power of 5, right? So we can simply write that in terms of 3 to the power of 5, then into 1 over 3 all to the power of n minus 1, right? Then now we need to simplify this problem here. So for us to simplify it so that it looks exactly the same as this here, we're going to say 3 to the power of 5 into, so we're going to write this in exponential form, so it's going to be 3 to the power of minus 1 to the power of n minus 1. So this n minus 1 will multiply any power that it finds inside. So it's going to be 3, so this is Tn equals to Tn. So it's going to be 3 to the power of 5 multiplied by, so this minus 1 multiplied the n is going to be 3 to the power of minus n multiplied by this minus 1 again will multiply the negative 1. It's going to be 3 to the power of 1, right? So we're going to add the exponents of these two terms here. So it's going to be Tn is equals to, so base 3, they have the same base, but the exponent is 5 and 1 here, so you're going to add both of them. It's going to give you 3 to the power of 6 multiplied by 3 to the power of minus n, right? Then we can simply write this as 3, which is the common base, and then we add the exponents, right? So it's going to be 6 minus n. So Tn, this Tn is now the same as this one here. Now in 2.1.4 we are asked to find the sum to infinity. So the formula for sum to infinity is a over 1 minus r, right? Of which our a value is 243, right? And our r is 1 over 3. So all these values, this one is just this one here, and this one we calculated it in previous questions. So we're just going to substitute that. So it's going to be 243 divided by 1 minus 1 over 3. So you're just going to punch that in your calculator to find the solution, which would be 364.5. So this is your solution of the sum to infinity. So now we're going to do 2.2. They say in the diagram below is a graph of some of the terms of an arithmetic sequence. The graph indicates that term number 8 is equals to 24. Let's look at the graph. Term number 8 is this one here. So if you go straight and this point, you get number 24, exactly what they said here, right? Exactly this. So term number 8 is equals to 24, right? And now in 2.2.1 we are asked to determine the constant difference for this sequence. So if you take a look, we're having a sequence here. Term number 5 is equals to 12, term number 6 is equals to 16, term number 7 is 20, term number 8 is 24, term number 9 is 28, and term number 10 is 32, sorry. So we can use any term here to find this constant difference, right? Because we know the difference between these two terms is actually the same, right? So the constant difference that I'm going to use here to find this. So you can note, if you take a look, term number 5 is equals to 12. Term number 6 is equals to 16, right? I'm just looking here and here. Term number 7 is equals to 20. Term number 7 is 20. So just by looking at these sequence 12, 16, and 20, the difference between these sequence is what? It's 4, right? 16 minus 12 is 4, 20 minus 16 is 4. So you can conclude by saying the constant difference of this question here is just going to be 4. So this is the constant difference that they're looking for. So now we're going to go to 2.2.2. They say calculate what term in this sequence will be equals to this number here, 124. So I want to know the term. So basically you're going to use the equation of Tn is equals to a plus into n minus 1d, right? Of which now we don't know the first term, right? But we know the difference. We know that d is equals to 4, and to find the difference we can use any term. We were told that term number 8 is equals to 24, right? Of which term number 8 is equals to a plus 7d is equals to 24, right? And to find the value of a, we're going to say a plus 7, our d is 4 equals to 24, and then we transpose this. So we're going to transpose this to the other side, we have a is equals to 24 minus 7 multiplied by 4. And then we find the solution of this. And then we find that our a value is equals to minus 4. So this is our solution of a, right? So now that we found our a value to be 4, it's going to be simpler for us to answer the question. So we're having our a value being equals to minus 4, we're having our d value being equals to 4, and our Tn is equals to a plus into n minus 1d, right? And we are asked to find the term such that it's equals to 124. So Tn is equals to 124, so meaning we're going to say 124 is equals to our a value, which is minus 4, plus into n minus 1, our d value is equals to 4. So you're going to say 124, and then you transpose the minus 4 to the other side. We have plus 4 is equals to the 4 multiplied by the n is 4n. 4 multiplied by negative 1 is minus 4, right? So when you add these two, you're going to get 128. And then you take the minus 4 to the other side. We have plus 4 equals to 4n. And then here it's going to be 132 is equals to 4n. And then you divide by 4 both sides, so your n value is equals to 33. So this is the solution of n required for 2.2. In 2.3, we are given this sum here, right? And 2.3.1, we are asked to find the sum of 4 terms, right? S4. So we're going to simply substitute that, because we are given Sn being equals to 5 into 1 minus 3 to the power of n divided by minus 2. So S4 is equals to, so this is 5, just so you know. So it's going to be 5 into 1 minus 3 to the power of 4. And then we divide by minus 2. So if you punch your calculator, you should get 200. So S4 is equals to 200. In 2.3.2, we are asked to calculate T5. So T5 is equals to the sum of 5 terms minus the sum of 4 terms. Remember that S4 is equals to 200, which is what we calculated in the previous question. So now we just want S of 5, which is equal to, so we're going to substitute it in this equation here. So it's going to be 5 into 1 minus 3 to the power of 5 divided by minus 2, right? And then your calculator will give you 605. So this would be your answer. So term number 5 is equals to S5 minus S4 equals to S5 being equals to 605 minus 200. And the answer you need to get is 405. So term number 5 rather, is equals to 405. Now we're going to do question 3. The statement reads as follows. In a storage room, there are sets of drawers that are used for storage. These drawers are packed in rows and numbered as shown in the diagram. So if you take a look at this first diagram here, it shows you the drawers. I mean, if you think about the realistic picture of a drawer, or a drawer, sorry, rather, it looks more like this, right? If you take a look at your kitchen drawers, they look more like this, right? So this is just a realistic picture of a drawer, and this is the drawing, which indicates the row. This is row 1, row 2, row 3, row 4, up to row n. Okay, so 3.1 says that the numbers of the last drawer in each row form a sequence. Determine the general term of the sequence. So what we are told here is this, that the last drawer of each row, so this is row 1, the last drawer is this one, the last drawer is this one, the last drawer is this one, and the last drawer is this one. So each last row form a sequence. So we have 3, we have 8, we have 15, and we have 24. So all these numbers are these ones here, right? So now we are told that they form a sequence, so we want a general term of this sequence. So if we can try and find a difference and see if it is a geometric or an arithmetic. The difference of 8 minus 3 is 5, so the difference here is 7, the difference here is 9. So definitely not an arithmetic sequence, but it looks more like a quadratic sequence, right? Because the second difference is constant, it's going to be 2, right? So to find the general term of this, so now we know it's a quadratic sequence. To find the general term, so we're going to say 2a is equals to the second difference, which is 2, and then divide 2 both sides, so our a value is equals to 1. So this is the a value, and now 3a plus b is equals to the first term of the first difference, which is this 5 here, so it's going to be equals to 5. 3 into a is 1 plus b is equals to 5. So we're going to transpose this 3 here to the other side. You have b is equals to 5 minus 3, which is equals to 2. So our b value is equals to 2, and then a plus b plus c is equals to the first term, which is this one here, 3, and our a value is equals to 1, our b value is equals to plus 2, and our c value. So we're going to transpose this to the other side, and you'll find that the 3 minus this 3 here will give you c being equals to 0. And knowing the standard standard formula of a quadratic sequence, it's Tn equals to an squared plus bn plus c, of which a we found to be 1, b we found to be 2, and c we found to be 0. So Tn is equals to n squared plus 2n plus 0. So we won't write 0. So this is the Tn that is required in this problem here in 3.1. Now in 3.2, how many drawers are there in row 8? So this is the first row, right? The first row consists of how many drawers? 3 drawers. This is the first drawer, this is the second drawer, this is the third drawer. So it consists of 3 drawers. The second row consists of 1, 2, 3, 4, 5 drawers. So it consists of 5 drawers, and row number 3 is 1, 2, 3, 4, 5, 6, 7. So it consists of 7 drawers. This 1, 2, 3, 4, 5, 6, 7, 8, 9. So it consists of 9. So we are asked to find the number of drawers in row 8, right? So we don't know row 8, but we know it's somewhere here. Row 8, so we want to know the number of drawers that it has, right? You want to know the number of drawers that it has. So for us to know it, we need to write down this sequence that I just wrote here. So we have 3, 5, 7, and 9, right? So for us to find the number of drawers of row 8, we need to find the general term of this sequence here. The difference of this sequence is 2, so it's constant throughout. So this means now that we can use the equation of an arithmetic. Tn is equals to a into n minus 1d, right, to find the general term of this sequence, of which our a value is equals to 3, which is this one here, and our d value is equals to 2, which is this one here. So it's going to be Tn is equals to our a value being 3 plus into n minus 1, our d value is equals to 2. So Tn is equals to 3 plus, so the 2 will multiply everything inside, so it's going to be plus 2n minus 2, and then Tn is equals to 2n these like terms, you subtract them together, you get 1. So this is the general term of this sequence here. So remember that we are asked to find the number of drawers in row 8. So meaning we have to substitute t of 8 in this equation here. So when we see n, we're going to put 8. It's going to be 2 into 8 plus 1. So the solution is going to be 17. So these are the number of drawers in row 8. 3.3, the manager bought 255 handles for the drawers. Determine how many complete rows will have handlers. Right, so we know that the total number of handlers are so it's total number of handles, sorry, not handlers. So the total number of handles that we have, it's 255, right? So this basically means the sum of handles that we have, and because we want to identify the number of rows that will have these handles, right, we need to use the sum. And remember that in this question we realize that we're using an arithmetic sequence. So we're just going to write the sum of an arithmetic sequence into 2a plus into n minus 1d, right? So this is the sum of the sequence of an arithmetic sequence, right? And we know the value of a to be 3, right? Remember in the previous question we had 3, 5, 7, and 9. And then our difference is 2. We calculated the difference in previous question to be 2. So yeah, we're just going to substitute that in the sum. So it's going to be sum of n is equals to n over 2 into 2. Our a value is 3 plus into n minus 1. Our d value is 2. And Sn is equals to n over 2 into 6 plus 2n minus 2. Right, and we know very well that the sum, because we want the number of complete rows that will have handles, so number of handles is 255, so the sum is 255, n over 2 into 2n plus 4, right? And then we cross multiply, so the 255 multiply the 2 equals 2n squared. This n will remain alone and it will multiply everything that it finds inside here. So it's going to be 2n squared plus 4n, right? So we are going to get this number here, 255 multiplied by 2, which would give you 510 is equals to 2n squared plus 4n, right? So now we are having 510 is equals to 2n squared plus 4n. So we're going to write it in standard form, which means we're going to transpose this to the other side. We have 2n squared plus 4n minus 510 equals to 0. We want to find the number of terms. We divide by 2 all sides. We divide by 2 all sides. We'll remain with n squared plus 2n minus 255, right? So this is the standard form, right? So now that we have the standard form, we can factorize now. So it's going to be n and n, and then it's going to be 15 and 17. So the larger number takes the sign of the middle term, which is positive. So it's going to be positive equals to 0 here, and it's going to be negative, right? And then n is equals to 15, or n is equals to minus 17. So n cannot be equals to a negative number. So this makes it the solution of n, which is equals to 15. So now we're going to do question 4. We are given the sketches below and the equations of the graph of f and the graph of g. and we are given point A and we're not given point B, and we are told that both graphs intersect at B and D, and we're also given the coordinate of E, right? So now let's look at the questions. So 4.1, we are asked to write down the length of AB. So how can we find the length of AB with the information given? So we are given that A is equals to minus 2 and 0, right? So this minus 2 is the horizontal distance, which is the x value, right? So meaning from this point of origin up to this point here, it's 2 units, right? Now we want the distance from the origin to this point of A, so that when we combine both of them, they give us the length of AB, right? So for us to find that, we need to find the coordinates of B, of which we're not given, but we know that B touches the straight line and the parabola. So the straight line, the equation is equals to x minus 6, and for B, the coordinates for B, we don't know x, but we know y is 0. So if we substitute 0 in this straight line, equals to x minus 6, and we transpose the 6 to the other side, x would be equals to 6. So it means now that the coordinates of B is 6 and 0. So the distance from here, from the origin to this point here, is 6 units, right? So the distance of AB will be equals to the 2 units plus the 6 units, giving us 8 units. So this is the length of AB. So now we're going to do 4.2. We are asked to find the coordinates of D, the turning point of F, right? So if you go back to this diagram here, and the equation of F, we are given the equation of F of X, which is this one here, and what we can tell is the x value of the turning point. This is the x value of the turning point. So the x value of the turning point is equals to 2, right? And we want to find the coordinates of D, right? So what we know is this, is that this is D and the coordinates is 2, and we don't know the coordinate of y, right? But we know that x is equals to 2, it's this line here, right? So for us to find the coordinate of y, we know that the straight line also passes through this point. So you can substitute from the straight line, which is y is equals to x minus 6, right? And we know the value of x of D is equals to 2. So let's find the value of y. So it's going to be equals to 2 minus 6. Y is equals to minus 4. So the coordinates for D would be 2 and minus 4. So these are the coordinates of D. So now 4.3, we are asked to show that the equation of F is equals to this expression here. So for us to show that, let's say we have f of x being equals to the a value into x minus x1, x minus x2, right? And our x-intercepts are what we're going to substitute here, right? How do we find the x-intercepts? So we know that the x-intercepts are the value of a and b. So a is minus 2 and 0, b is equals to, so we found b to be equals to 6 and 0 from the previous questions. And now we're going to substitute the x-intercepts where there's x1 and x2. So f of x equals to a into x minus 2, x minus 6, right? So f of x is equals to a into x plus 2, x minus 6, right? So having this equation of f of x equals to a into x plus 2, x minus 6. Let's substitute a point so that we can find this value of a. An equation is not complete until you find the value of a. So for us to find the value of a, we must substitute a point. Because this is a graph of f and we know the point of D now being equals 2 and minus 4, so we can simply substitute that. So where there's y, put minus 4 is equals to a into, where there's x, you're just going to put the value of 2. So it's 2 plus 2 into 2 minus 6. So this is minus 6, and then minus 4 is equals to a into 4, and 2 minus 6 is minus 4. So it's going to be minus 4 is equals to a into minus 16. Divide by minus 16 both sides. A value is equals to 1 over 4. So this is the a value. F of x is equals to a into x plus 2 x minus 6, of which our a value is 1 over 4, so it's going to be 1 over 4 into, finding the product here, you're going to get x squared minus 6x plus 2x minus 12, which is 1 over 4 into x squared minus 4x minus 12. Right, so now we're going to multiply the 1 over 4 inside every term that it finds, and then we're going to get x to the power of 2, x to the power of 2 over 4 minus 4x over 4 minus 12 over 4. So the solution would be the following. I'm just going to write it here. So now we're having this expression here, which is f of x. So the solution for this would be f of x is equals to x to the power of 2 over 4 minus x minus 3. So this is the solution of f of x. So now we're going to do 4.4. The question says that determine the value of k if E is the reflection of C with respect to the axis of symmetry, right? So now we want to identify the value of K. Remember that the coordinates of C were calculated as 0 and minus 3, right? So these are the coordinates of C. And we are told that they are a reflection of the axis of symmetry. So this is the axis of symmetry, and we know that the x value of the axis of symmetry is 2, right? So if these coordinates were reflected about the axis of symmetry to give this coordinate of E, it means now that where there's going to be a change of values, right? What do I mean by that is this value of x being equals to 0, here at E, it's no longer 0, right? So it was 0 from C, but it's going to be 4, right? 4 units. So the only change here is the x values, right? Because it's moving in a vertical form, right? So for the mere fact that it's moving in a vertical, so only the x values are changing. X was equals to 0 here, and now x is equals to 4 here. But the y values remain the same. So here, the y value was equals to minus 3. The y value will remain here. So the coordinate of E will be 4 and minus 3. So meaning that our k value is equals to minus 3. So that is how we find this k being equals to minus 3. Now, doing 4.5 says that determine the equation of the tangent to the curve at E if the tangent is parallel to G. So we're going to this diagram here. So let me first erase everything here. So now we are to write down the equation of the tangent, right? and we are told that the gradient of the tangent and that of line of G. So this is our graph of G here. So this one here is our graph of G. We are told that the gradient of G is parallel, right? So the gradient of G is parallel to the gradient of T, of tangent, meaning that parallel gradients are equal. So meaning that the gradient of G will be equal to the gradient of the tangent. So let's have a look at the gradient of G. So there it is here, it's equals to 1. So m of G is equals to 1. That means m of tangent is equals to 1, right? So now that we know the gradient of the tangent, so we know the equation is equals to mx plus c, where the gradient is equals to 1. So y of t is equals to x plus c, right? And we are told this statement here that the gradient, the tangent to the curve at E. So it means now that the tangent passes through point E. So chances are it might look something like this, right? So this would be the tangent. So this means now that we will use the coordinates of E to find this value of C, right? So these are the coordinates of E. So you're going to substitute, this is X value, this is Y value. So where there's Y, we're going to put minus 3 is equals to, where there's X, we're going to put 4 and then plus C. Transpose the 4 to the other side, we have minus 3 minus 4 is equals to C, which would be minus 7 is equals to C. So this would be the C value. And the equation of the tangent would be y of t is equals to x minus 7. So this is the equation of the tangent. Okay, now 4.6, we are asked to find the values of x such that f of x minus g of x is less than 0. Right, so we can just transpose the g of x to the other side and you'll have f of x is less than g of x. So always remember, when you talk of f of x, we're talking of the value of y. When you talk of g of x, we're talking of the value of y. So you're looking at the behavior of the value of y in the graph of f of x and the graph of g of x. So what we're going to look here is we're going to look at a point where, or points rather, where the graph of f is less than the graph of g, and we want the values of x when that happens. So where in the, so remember that this is your graph of f, this is your graph of g. So we want a point where f of x is less than g of x. Where does that happen? So this is f of x, remember this is f of x, it's below g of x at this point, it's below, and this is g of x, it's above, right? So this is the point where that happens, where this is f of x and this is our g of x. G of x is above. So these are the points. So points are here D and B, where f of x is less than the g of x. So you need to write the x values of that situation. So x here is equals to 2, and here x is equals to 6, right? So when x lies between, so you can either use lies between, or you can say when x is greater than 2 or x is less than 6, you can just simply use these solutions. Or someone can just say when x lies between 2 and 6. So someone can simply write this here, will also be correct. 4.7, determine the coordinates of the turning point of h. If h of x is equals to f of x plus 2 plus 1. Okay, cool. So we are asked to find the turning points, right? Remember, this is f of x. We identified the equation previously. So f of x is equals to x squared over 4 minus x minus 3, right? And also remember that we already know the turning points of the graph. We identified the turning points in the previous questions. How did you identify them? We know the turning point of D, right? We know the coordinates of D to be what? To be 2 and minus 4. So that is the turning point. So we can simply write our f of x in this format. We know the value of it's ax plus minus p squared plus q, and we know our value of a, it's 1 over 4, and then as I said, d is 2 and minus 4, right? So our x value is going to be minus 2 here squared and then minus 4, right? So this is our f of x, and we are told that h of x is equals to f of x plus 2. So where there's x, we're going to add 2. So what this means is you have f of x is equals to 1 over 4 into, so instead of writing this x, you're going to write x plus 2. It's going to be x plus 2, and then you write this minus 2 here, so it's minus 2 all squared, and then you're going to write plus 1, right? So it's minus 4 plus 1. So that is going to be your h of x. So let me remove this here since I substituted the values. So it's going to be your h of x, the equation of the h of x. And remember, we want to find the coordinates of the turning point. So it's going to be h of x is equals to 1 over 4 into, so the 2 and the minus 2 will cancel out, so it's going to be x squared, and minus 4 plus 1 is going to be minus 3. So we can tell from this equation the turning point of it. The x value of the turning point is equal to 0 because here it's only x, and the y value, or the q rather, is equals to minus 3. So the turning point of the graph of h of x is going to be 0 and minus 3. We're going to do question 5. We are given the function here of f of x being equals to this equation here. And 5.1 asks us to write down the equations of the asymptotes of f. So looking at this equation, we can tell that the vertical asymptote is equals to 1, and the horizontal asymptote is equals to minus 1, right? So that is your vertical asymptote, and that is your horizontal asymptote. 5.2, we are asked to calculate the intercepts with x's, right? So you have your f of x being equals to minus 2 over x minus 1 minus 1. So you're going to calculate your intercept, your x-intercept, when y is equals to 0, right? So where does y equate to 0? So it's going to be 0. It's going to be 0 is equals to minus 2 over x minus 1 minus 1. And then this minus 1, we transpose it to the other side. We have 1 is equals to minus 2 over x minus 1. And then we cross multiply. We're going to have x minus 1 is equals to minus 2. And then we transpose the minus 1 to the other side. We have x is equals to minus 1 plus 2, right? And then we're going to have x is equals to minus 2 plus 1. And x being equals to minus 1. So our coordinates of the x-intercept is going to be minus 1 and 0. And now to find the y-intercept when x is 0, so it's y-intercept when x is equal to 0. So we're just going to put 0 there. So it's going to be f of 0 is equals to minus 2 over 0 minus 1 equals to minus 2 over minus 1 equals to 2 minus 1 is equals to 1. So our y-intercept coordinates going to be 0 and 1. So these are our x and y intercepts. So now going to 5.3, we are asked to sketch the graph of f showing all asymptotes and intercepts of x is. So what we're going to do is we're just going to draw it somewhere here and indicate all our intercepts and our asymptotes, right? So this is a hyperbola, so we're just gonna draw. It's gonna look something like this, all right? And we're gonna label our graph. So it's going to be the y, it's going to be x, and we're going to first identify the asymptotes, right? So we have our vertical asymptote being equals to 1, so meaning it's going to be somewhere here. So our x equals to 1, and our horizontal asymptote being equals to -1, which would be somewhere here. Y is equals to -1, right? And we're going to identify which quadrant this hyperbola lies. So if you take a look, this is -2, right? So a is equals to -2, meaning a is less than 0. So when a is less than 0, our graph lies in the second quadrant and fourth quadrant. So we know it's going to lie in the second and fourth quadrant. But before we do that, we need to indicate our intercepts. This is our x-intercept, where y is 0, so x is -1 here. And then, so let me just indicate the coordinates. It's -1 and 0. And then we have this intercepts where x is 0 but y is 1, right? So which would be somewhere here where x is 0, y is 1. And then we draw our graph. So it's gonna look something like this, not touching our asymptotes, going to move like this, and another one would be somewhere here. So this is our graph of f. Now in 5.4 we are asked to determine the equation of the axes of symmetry of f with a negative gradient. So the axis of symmetry of this graph here, the negative one, is this straight line. It passes through here. So this would be the negative axis of symmetry. It's decreasing, right? Let me remove this. So this is a decreasing axis of symmetry of this hyperbola, where our m is equals to -1, right? So to find the equation, remember that it passes through the origin of the asymptote. So the coordinates of the asymptotes being our x being equals to 1 and our y being equals to -1. So to find the equation, we're going to first show our gradient, right? So we're going to show our gradient, and then after doing that, we're going to use the points of the asymptotes to identify the value of c. So it's going to be y is equals to mx plus c, but because it's a decreasing or a negative symmetry of f, where m is equals to -1, so it's going to be y is equals to -x plus c, and then we're going to substitute the asymptote values, which is 1 and -1, and write down where there's x, we're going to put 1, where there's y, we're going to put -1. So it's going to be -1 is equals to minus into 1 plus c, and then the -1 we transpose to the other side is going to be c is equals to -1 plus 1. So c is equals to 0, right? So the equation is going to be y is equals to -x. So this is the negative axis of symmetry, the decreasing axis of symmetry equation, which is y is equals to -x. So now we're going to do question 6, where we are given this equation of our graph, which is f of x equals to log of base a x, right? And we are given a point which is 4 and -2. So there is the point there in the graph, and we also know the x-intercept, which is 1 and the y being equals to 0, right? So that is the information from the graph, and we are asked in 6.1 to identify or show that a is equals to 1 over 2, right? So remember that we have our f of x there, our f of x being equals to log of base a x, and we're asked to prove that a is equals to 1 over 2, right? So this is the requirement to show that. So how do we show that? We're going to use this point here, right? The point of 4 and minus 2, right? So you can substitute it in this equation here. So where there's x, you're going to put 4, where there's y, you're going to put minus 2. So it's going to be minus 2 is equals to log of base a, and then where there's x, you put 4 there, and then this base here will be equals to, it's going to be a to the power of this minus 2, so it's going to be minus 2 equals to this 4 here, which is equals to 4. And we can either multiply by 1 over minus 2, or we can just say 1 over a to the power of 2 is equals to 4, and then we cross multiply. We're going to have 1 is equals to 4a to the power of 2, and then you divide by 4 both sides, and we'll have a squared is equals to 1 over 4. So this is a squared is equals to 1 over 4, and then we'll put the square roots both sides, and then we'll have a is equals to plus or minus 1 over 2, right? But we know that our base is going to be positive, so it's going to be a is equals to 1 over 2. So we've proven that a is indeed 1 over 2. So now 6.2, we are asked to determine the equation of the inverse, right? So remember that we just proven in the previous question that a is equals to 1 over 2, so our f of x is equals to log of base 1 over 2x, right? So to find the inverse of this, we know that f of x is equals to y, so you can simply write y is equals to log of base 1 over 2x, and then we can swap our x and y. Where there's x, we're going to put y. Where there's y, we're going to put x, right? So here we're just going to write x, and here we're just going to write y, right? So it's going to be x is equals to log of base 1 over 2y, and then we write our equation properly. So this 1 over 2 will be to the power of x, right? It's going to be 1 over 2 to the power of x is equals to this y here, which is equals to y. So our y is equals to 1 over 2 to the power of x. So this would be our inverse. So this is 2 here. So it's y is equals to open bracket 1 over 2 close bracket to the power of x. So that is our inverse of the function of f. So now 6.3, we are asked to write down the equation of h if h is the reflection of f in the x-axis, right? So we want to find the equation of h if h is the reflection of f in the x-axis. So h is the reflection of f in the x-axis. So this is really important. Where is the reflection happening? In the x-axis. So this is our x-axis, x-axis, right? So the graph reflects about the x-axis. So for us to find it, we know very well that if it reflects about the x-axis, it means now where here it's the coordinate is 4 and minus 2, right? So if it reflects about this x-axis here, if you wanted the same point here, but here you will find that the coordinates, the 4 remains the same, but the y changes. So the y was negative 2 here, but now it's positive 2, right? So you're going to use these these coordinates now, because they are a reflection about the x-axis. They are a reflection about the x-axis. So you're going to use them to find the equation of h of x, right? So remember that our f of x was equals to log of base 1 over 2x, right? But now, since we're having this reflection, we can simply say our h of x is equals to log of base. We can still maintain our base, or we can just write a and x like this, right? And then substitute these coordinates. So where there's x, you're gonna put 4. Where there's y, you're gonna put 2, right? So it's gonna be 2 here equals to log of base a and 4 there to find the value of a, right? So it's going to be this a here to the power of 2 is equals to this 4 here. It's going to be a to the power of 2 is equals to 4, and then you put the square root both sides, so our a value is equals to plus or minus 2. We're going to take the positive 2, so a is equals to 2. So now we found the equation of h of x. So h of x is equals to log of base 2 x. So this is the equation of h of x. So 6.4, we are asked to determine the values of x for which log of base a x plus 4 is greater or equals to 0. So how we find the values of x for this, for this expression here? We know very well that x plus 4 must be greater or equals to 0. Or let me just say that we transpose the 4 to the other side, we will have x being greater or equals to minus 4. So this is the first solution of x that we should expect in our solutions. And the second solution can be, we have log of base a into x plus 4, right? Greater or equals to 0. So this a here will be to the power of 0, remaining x plus 4. So it's going to be x plus 4 is greater or equals to a to the power of 0. Anything to the power of 0 is 1, so it's going to be x plus 4 greater or equals to 1. So this x plus 4 greater or equals to 1, and then you transpose the 4 to the other side, we have x being greater or equals to 1 minus 4, right? So it's going to be x greater or equals to minus 3. So this would be the second solution of x. So remember, this is the first solution of x, the second solution of x. So now you need to analyze your solutions now. So we have x being greater or equals to minus 4. We have x being greater or equals to minus 3. So you're going to go back to your equation, this equation here, right? So you have log of base a x plus 4, right? So we want a solution of x that when we substitute it here, it's going to give us a solution that is greater or equals to 0, right? So a solution that is positive or equals to 0, right? So if we substitute x being equal, if we look at this minus 3 here, if we substitute x being equals to minus 3, it's going to be log of base a minus 3 plus 4. So when you add minus 3 plus 4, it gives you a positive value, right? It gives you a positive 1. Right, minus 3 plus 4 it's 1, so it's going to be log of base a 1, right? So this can definitely give us a solution that is either greater or equals to 0, right? So that tells us that x greater or equals to minus 3 is our solution. But now let's test for, because it says greater or equals to minus 3, right? Let's test x being equals to minus 4. So we have log of base a minus 4 plus 4. So minus 4 plus 4 gives us log of base a 0, right? Which you can still consider it, considering the fact that minus 4 is also one of our solutions here. So you can still consider this one here. But now let's test another value that is greater, because this says greater or equals to minus 3. So let's test a greater value also. We're going to test x being equals to minus 5. So if we are to say log of base a minus 5 plus 4. So minus 5 plus 4 gives you a log of base a minus 1. So this doesn't give you a solution. right? It doesn't give you a solution. So it tells you now that this solution of x here that we found, being greater or equals to -3, should not exceed -4. So x being greater or equals to -3, right? But x must not be, let me write it properly, x must not be greater or equals to -5. So it must either remain, it must be less than or equals to -4, but it must also be greater or equals to -3, right? So let me properly write that, but at least I showed you the situations on what happens. But as long as now we know the final step of this problem here, since we tested. But if you didn't understand what I was doing, please write your questions or just comment in the comment section below. But as we concluded, or as we tested, we know that x must be greater or equals to -3, but x must also be less than or equals to -4, because if x is equals to -5, it gives you a negative log, because it's x plus 4, where if you substitute log, so this is a base a minus 5 plus 4, so it gives you a negative log. It's log of negative, it's -1 base a, so which won't give you a solution. Hence I say x must be greater or equals to -3, or x must be less than or equals to -4. So someone can simply write it as x must lie between -3 and -4. So both these are correct. So that is the solution of your values of x. Okay, so now we're going to do question 7. 7.1 says that Tandy decides to invest 45,000 Rand into the savings account. She charged an interest rate of R%, compounded half yearly. After 5 years, the investment matures and she receives this amount of 66,611. Calculate the interest rate, right? So we know that this is a compound formula. First of all, a is equals to p into 1 plus I to the power of n, right? And what we need to remember is this was the investment, so this is p, right? And this was the accumulated amount, so this is a, and the interest rate that is required is going to be I, and the investment was for 5 years, so this is going to be n, right? So you're just going to substitute everything in the formula. So we're having a being equals to p into 1 plus I to the power of n. Remember that I said a is equals to 66,611, and then p is equals to 45,000 Rand, and then I we don't know, but n is 5 years. And another thing that we need to note is that this investment was compounded half yearly, right? So this portion here is really important. So it's compounded half yearly, so it means it's compounded half yearly, right? So it's compounded half yearly, so which means we're just going to divide by 2 here and then multiply by 2 there. So let's just substitute everything in this equation here. So instead of writing a, you're going to write 66,000 Rand. 611 equals to 45,000 Rand into 1 plus interest rate we don't know, but we know it's compounded half yearly, so it's divided by 2 to the power of 5 years multiplied by 2 because it's compounded half yearly. And then we're going to divide, because we want this I here, so it's just going to divide by 45,000 Rand both sides. So it's 45,000 Rand, and we will have 66,611 divided by 45,000 rand is equals to 1 plus I over 2 to the power of 10 now, because 5 times 2, and we still need what's inside, right? So we can multiply by 1 over 10 to remove this 10 here, so it's 1 over 10, and we will have 66,611 over 45,000 to the power of 1 over 10 is equals to 1 plus I over 2 now, right? So you're going to transpose this 1 to the other side, so you're going to have 66,611 over 45,000 minus 1 is equals to I over 2, right? We still need I, right? So we're just going to remove these 2 at the bottom by cross multiplying like this. So it's going to be 66,611 over 45,000 minus 1, and then you multiply by 2 equals to I. So I hope you can see that I didn't punch my calculator up until this point. The reason being is you don't want to be rounding off prematurely as you solve the problem, because it will be slightly different to the final answer. So you need to punch towards the end of your solution. So now that we reach this point of finding I, you can simply punch in your calculator this whole expression here. And if you round off to 2 decimal places, you should have I being equals to 0.08, right? Which would give you, if you multiply it by 100, because this is a decimal, so you have to multiply it by 100. Sorry, not 1,000, but you multiply it by 100. It will give you 8%, right? So this is the interest rate of this problem here. Now, we're going to do 7.2 here. The question says that on the 30th of June, on the 30th June 2013, and at the end of the month thereafter, Jonathan deposited 2,500 rand into the bank account that pays 6% compounded quarterly. He continues to deposit this amount up until the 30th of June, right? So he started at the depositing on the 30th of June, right? Because the statement says that on the 30th of June 2013 and at the end of each month, right? From the 30th and at the end of each month, he or she deposited, I'm assuming Jonathan is a he, so he deposited, yes, it's a he deposited 2,500 right into the bank account that pays 6% per annum compounded quarterly. So we need to draw our number line to represent this information here. But let's check the question. How much money will Jonathan have in his account immediately after depositing 2.5 on the account? So we want to know the amount that he will have. Excuse me. So I want to know the amount that Jonathan will have. So these are savings, right? So these are savings of Jonathan. So we know very well that we're going to use the future value annuity, because we want to know the future value, the amount that he would have accumulated if he made monthly installments, or monthly payments rather, monthly savings, whatever you call it, of 2.5, right? So we are going to draw to represent the information. So we know this is our timeline. It starts at T0. T0 is the 30th of June 2013, right? So it starts here. So the payment of 2.5 starts here, and they end at T20, right? Why am I saying T20? Remember that it's from 2013 up until 2018, right? Simply do the math. It's 5 years, right? From 2013 to 2018 is 5 years, right? And remember that our interest rate of 6% is compounded quarterly, right? So the payments are made quarterly, or the interest that is earned, is accumulated quarterly, right? So if it's quarterly, it's going to be 5 times 4 being equal to 20. So hence I wrote 20 there, right? So it's not necessarily 20 years, it's just 20 payments made. We know that it's 20, it ends at 30 June 2018. So our feature value formula, which is written like this: 1 plus I to the power of n minus 1 divided by I, right? So the feature value is equal to, so we know the payments, it's 2.5, 1 plus our interest rate, it's 0.06 quarterly. So and what is our n? Remember that it started off immediately at t0, right? So if it's t0, it means now to find n, we're gonna say the 20 minus 0 plus 1. So the 20 is 20 minus 0 where it started plus 1, which will give you 21. So our n is 21. It's going to be minus 1 there, right? And then we divide by 0.06 over 4. So you're just going to punch your calculator the entire thing here and find the feature value annuity, which would be 61,176.31. So this is the solution for this problem here. So now we're going to do 7.3. It reads as follows. On the 1st of February 2018, Genevieve, oh gosh, I can't pronounce his name. Sorry for butchering it. Genevieve took a loan of 82,000 Rand from a bank to pay for her studies. She will make her first payment of 3,200 Rands on the 31st of July 2018, and will continue to make payments of 3,200 Rands until she settles her loan. The bank charges her an interest rate of 15% compounded annually, compounded monthly. 7.3.1, calculate how much Genevieve will owe the bank on the 1st of July. So we need to note that she took a loan of this amount of 82,000 Rand on the 1st of so this is the loan. Let me just write loan here. Loan taken on the 1st of February 2018, and then she didn't pay after that up until it was the 31st of July. So that was the first payment. So normally when you take a loan from a bank, or let me just say in according to our financial maths, when you take a loan, you must make payment 1 month after taking the loan. So that's the normal way of paying the loan, right? But there are different conditions where you'd pay immediately if you want, or you'd miss payments, because once you miss payments, obviously there's going to be a problem with that. So in this case, she did miss payments because she was supposed to pay 1 month after taking the loan. So this is the payment of, so this is going to be the payment that she made, payments of 3,200 Rands to settle the loan. So fine. So now we want to know how much she will owe the bank on this date of the 31st, on the 1st of July 2018. So for us to solve this problem, we must draw a timeline to indicate. So we already know the amount that she will pay, the amount that she owes, right? So the loan is 82,000 rand, and payments that she made are she made payments of 3.2 thousand, right? 3,200 rands. Now, want to know how much she'll owe, right? Let's first draw our timeline and indicate that at T0 it's when she took the loan in 2018, right? So she took a loan and didn't make payments up until we reached the 1st of July, right? Then that's when she made her first payment of 3,200 rands, right? Yes, that's what the statement says. So we can simply say from the 1st of February up until the 28th of February, provided it's not leap year, 2018, to the 30th of March. Let me just assume it ends on the 30th. And then we have April, 31st April 2018. Then you go to May, 30 May 2018, and then this is June, sorry. So this is very important. I'm writing this because it's important. So remember, I said normally the payment is made here after taking the loan. 1 month after taking the loan, you make payments on the 28th of February, right? But she didn't make payments, right? And she didn't make payments here, she didn't make payments here, so started making payments here. So we need to calculate the missed payments. So I'm just going to shade the missed payments. So this is going to be 1. I'm just going to shade the gaps, right? 1, 2, 3, 4, 5. So these are the missed payments. So all of these green shades are missed payments. So you need to count how many are these green shades. It's 1, 2, 3, 4, 5. So it means now we have 5 missed payments, right? So we need to know how much she owes the bank, since she missed 5 payments. So what we're going to do is, we know the interest rate is equals to 15% compounded per annum, compounded monthly, right? So we're going to solve this problem by using the compound formula, because we want to identify the amount that she owes since she missed 5 payments, right? So it's P into 1 plus I to the power of n, and the loan that she took is 82,000 rand into 1 plus the interest rate 0.15 divided by 12, because it's compounded monthly, to the power of 5. This 5 means the 5 missed payments, just so you know. And then you're going to punch your calculator. You should get 87,254.74. So this is the amount that she owes the bank since she missed 5 payments. Then now 7.3.2 says that how many installments of 3,200 rand must she pay to settle the loan. So now we know the loan is 87,254. So we want to know the number of payments that she'd have to make if she pays 3,200 rands, right? So we know very well that the equation for the loan is the present value annuity, which is equals to x into 1 minus into 1 plus I to the power of minus n divided by I, right? And the loan is this one here, which is 87,000 rand, 254. So it's 87,254.74, right? Equals to, and then she made payments of 2,000 rand. She made 3,200 payments every month. So it's 1 minus into 1 plus the interest rate is 15%, so it's 0.15 divided by 12, and we want to know the number of payments, so it's going to be minus n, right? Close bracket divided by 0.15 over 12. So now we're going to find this n because we want to know how many payments will she make. So what you're going to do is we're going to cross multiply, so it's going to be 87,254.74. Yes, it's 254.74. Everything is written correctly from here. So it's going to be multiplied by 0.15 over 12, this one here, and will be equated to 3200 into 1 minus into 1 plus 0.15 over 12 to the power of minus n, and close brackets. Then from here we're going to divide by 3200 divided by 3200, then you're going to have 87,254.74 multiplied by 0.15 over 12 divided by 3200 equals to 1 minus into 1 plus 0.15 over 12 to the power of minus n, right? So what we'll do from here is, this is 5, just so you know, and we're going to transpose this one to the other side. So it's going to be 87,254.74 times 0.15 over 12 divided by 3200 minus 1 equals to minus into 1 plus 0.15 over 12 to the power of minus n, right? So from here we are just going to, because we want n, right? We want n, so let's punch this expression here in our calculator. So I hope you see that I always punch towards the end because I don't want to get premature answers, you know. So let's just first punch this huge number into our calculator. So you should get negative 0.65916. So it continues. Just gonna write it into 5 decimal places, being equals to minus into 1 plus 0.15 over 12 to the power of minus n, right? And then the negative will divide out, you'll remain with 0.65916 equals to 1 plus 0.15 over 12 to the power of minus n, right? So now we're going to use logs. So it's going to be minus n is equals to log of our base 1 plus 0.15 over 12 and then 0.65916 here. So you're just going to punch this in your calculator. You should get minus 33.55, which when you divide by negative 1, you get n being equals to 33.55. Because we want the number of installments, we can't write 33.55, right? You can just approximate and say n approximates 33 payments. So these are the number of payments that she will make to settle the loan. So now we're going to do question 8. 8.1 says that from first principles, determine the derivative if f of x is equals to 4x squared minus x. So we're going to use first principles to find the derivative of this problem here. So you have f of x be equals to 4x squared minus x, right? Meaning f of x plus h would be 4 into x plus h squared minus x plus h, right? If you write it, it's going to be x plus h minus x plus h, and we'll have x squared plus x multiplied by this is going to be xh, and this one here plus xh plus h squared minus into x plus h, and we'll have 4 into x squared plus 2xh plus h squared minus, so close bracket, minus into x plus h, right? So let's leave it here for now, our f of x plus h. So now let's find the derivative. So we have the derivative equals to the limit when h approaches 0, f of x plus h minus f of x divided by h. So the limit when h approaches 0, so what is f of x plus h is this expression here. So it's 4 into x squared plus 2xh plus h squared, close bracket, minus into x plus h, right, divided by h. Then we're just going to multiply the 4 inside here. So we're going to have oops, so we have the limit when h approaches 0. So what is f of x plus h? It's this expression here, which is 4 into x squared plus 2xh plus h squared, close bracket, minus x plus h, right? So this is f of x plus h minus, what is our f of x? Our f of x is this one here, so it's going to be 4x squared minus x, right? And then we divide by h, so it's divide by h, right? So the limit when h approaches 0, so we're just going to multiply the 4 inside here. So it's going to be 4x squared plus 8xh plus 4h squared minus x minus h, right? This minus will multiply everything that is inside. So it's going to be minus, this minus will also multiply everything that is inside here. So it's going to be minus 4x squared plus x divided by h, right? So we're just going to have, so we're going to have limit when h approaches 0, so it's going to be 4x squared plus 8xh plus 4h squared minus x minus h excuse me, minus 4x squared plus x, so it's plus x there, divided by h. So now we're going to cancel out this minus 4x squared with this plus 4x squared, and the x goes away with this x, and then we remain with these expressions here. So it's going to be the limit when h approaches 0, so it's going to be 8xh plus 4h squared minus h over h, right? So we can factorize h, we can factor out h. So it's going to be h into 8x plus 4h minus 1 divided by h. So this h will divide out with this h, so you have limit when h approaches 0, so we have 8x plus 4h minus 1. So where there's h, we're going to substitute 0, so it's going to be 8x plus 4 into 0 minus 1, and we'll have 8x plus 0 minus 1, which is equals to 8x minus 1. So this is our derivative of f of x using first principles. So now we're going to do 8.2, where we are asked to determine in 8.2.1 the derivative of this expression here. So we have d of x into x squared minus 1 over 2x cubed plus the root of x, right? So the first thing before we derive, we need to change this root of x, right? So it's going to be d of x into x squared, and we're going to take this up because we want to derive it. So it's going to be minus x to the power of minus 3 over 2, and then plus x to the power of 1 over 2, right? So now we can derive this expression. We will have 2x, the derivative of this, and minus into, we'll drop the minus 3, so it's going to be minus 3 multiplied by x over 2 to the power of minus 3 minus 1, and plus, so let me close bracket here, so it's plus 1 over 2 into x to the power of 1 over 2 minus 1, right? So we have 2x plus, because the negative multiplies the negative, 3x to the power of minus 4 over 2 plus x to the power of, so 1 over 2 minus 1 will give you minus 1 over 2 divided by 2, right? And then we'll have 2x plus, so we can't leave it like this because can't leave it like this since the exponents are negative, so we need to make sure that the exponents are positive, so we need to drop this expression down. So it's going to be 3 over 2 x to the power of 4 plus, so there's 1 here, so it will remain, and then we drop this expression down, so it's going to be 2x to the power of 1 over 2 like this, right? So now you can leave it like this if you want. This can be your final answer, or you can simply write it as 2x plus 3 over 2x to the power of 4 plus, so let me write this, so it's going to be plus 1 over 2 root of x. So this can be your final solution, or you can write this one as your final solution. Do 8.2.2. We're going to find the derivative of this expression here. So we're having y is equals to k minus 2p to the power 2. So to find the derivative, to find the derivative, we have to expand this first, right? Because the derivative must be d of y over d of k. So you're just gonna say k minus 2p, k minus 2p, and find the product. So k multiplied by k is k squared, k multiplied by 2p it's minus 2pk, and minus 2p here also multiplied by k, so it's minus 2pk, and then plus this minus 2p multiplied by minus 2p is plus 4p squared. So to write this nicely, we're going to k squared minus 4p of k plus 4p squared. So this is y is equals to k squared minus 4pk plus 4p squared. So we're going to derive the expression of y with respect to k, right? So we're going to derive this k squared, so it's going to be 2k. And if we derive this, it's going to be minus 4p, because we're deriving it with respect to k, right? We're deriving k with respect to y. So then this one here is going to be 0. So it's just going to be plus 0. So d of y over d of k is equals to 2k minus 4p. So this is the solution for this problem here. We're going to do 8.3, where we are given functions f of x and g of x, and we are told that they share the common tangent at point x being equals to 2. Calculate the value of p. So what we know is that the tangent passes through f of x, it also passes through g of x at x is equals to 2. So for us to find this value of p here, we first need to find this value of g of x, because already here we know x is equals to 2, right? So if we can find this g of x, then we'll be able to find the value of p. So for us to find g of x, which is actually y, we need to substitute in f of x. We have f of x being equals to minus x squared plus 9, right? We want to find the y value. So we know that x is equals to 2, right? Why am I substituting this in this f of x? Is because the tangent passes through f of x and g of x. So the y value of f of x is the same as the y value of g of x, right? Cool. So let's substitute this x is equals to 2 inside the f of x, right? We're going to substitute 2, so it's going to be 2 squared plus 9 is equals to minus 4 plus 9 being equals to 5, right? So our y value is equals to 5, and our x value is equals to 2. So now having these, we are going to find the value of p, right? Using the equation of g of x. So in g of x, it's g of x equals to p over x minus 3, right? And I said g of x is the same as having y. So it's y is equals to p over x minus 3. So where there's y, you'll put the 5. So it's going to be 5 equals to p over the x is 2 minus 3, right? So we have 5 equals to p over 2 minus 3, and then you transpose the minus 3 to the other side. We have 5 plus 3 equals to p over 2. We have 8 here is equals to p over 2. You cross multiply, p is equals to 16. So this is the solution of p. So now we are going to do question 9. We are given f of x being equals to 2x cubed minus 3x squared minus 72x minus 35. And we are given point A of the cubic function here, and we're given B and C, which are the points here. They're indicated as the x-intercepts, and we're given D and E, which are the turning points of our cubic function. So another one here, right? So the first question says that we must identify the coordinates of B and C. So the coordinates of B and C, so for us to find the coordinates of B and C, we need to know what B and C is. B and C are the x-intercepts of the cubic function. So for us to find them, we already know the y values here are actually 0, y is equals to 0 here, and y is equals to 0. So we need to know what the value of x is when y is 0. So for us to find, we need to use this equation here for us to find the coordinates of B and C, right? So what I'm going to do is I'm going to factorize it. So, but we can't just factorize it. So you have 2x cubed minus 3x squared minus 72x minus 35, right? So we need to first factorize this expression here. So for us to factorize this expression here, we need to equate f of x to 0, right? So 0 is equals to 2x cubed minus 3x squared minus 72x minus 35, right? So for us to factorize this expression here, we also need to substitute a value here where there's x. We need to find a value of x such that when we substitute, it gives us a solution of 0, right? So you're going to test x is equals to 1. So meaning you're going to substitute x equals to 1 where there's x and see if it's going to give you 0. Uba umsindo man. Tshela mama kuba umsindo. So when x is equals to 1, you need to substitute that x equals to 1 where there's x and see if it's going to give you 0. If it doesn't give you 0, try substituting x equals to minus 1. If it also doesn't give you 0, try substituting x equals to 2 or x equals to minus 2, x equals to 3, or x equals to minus 3, right? Just try and substitute the values of x, where there's x here, and see if it's going to give you a solution equals to 0. So I found that x equals to minus 5 does give you 0. So if you substitute x being equals to minus 5 in this expression here, it will give you 0. So that means that x equals to minus 5 is going to be our factor. So writing it in factor format, it's x plus 5, right? Because we take the minus 5 to the other side. So this is our factor. So it's critical for us to find the factor because it will help us factorizing this problem here. So now we know our factor. So our factor is x plus 5, right? Which is x equals to minus 5, right? So we can factorize our expression. Our expression of f of x is equals to 2x cubed minus 3x squared minus 72x minus 35, right? So for us to factorize, we're going to use this method here, where our x is equals to minus 5. And then we're going to write the coefficients. All these coefficients, we're just going to write them. And then we're going to write that 35 here, minus 35. So the first coefficient is 2, the second one is minus 3, the third one is minus 72, and then minus 35. So remember, I'm just writing these coefficients here, and then this minus 35. Then we're going to start at 0, so you always write 0, and then you add. So that's why I'm going to write plus here. So we're going to say 2 plus 0 is 2. And then this 2 multiplied by this 5 here, minus 5 rather, is going to give us minus 10, right? Did you get that? This 2 plus 0 gives us 2. 2 multiplied by minus 5 gives us minus 10. And then you repeat the process. And then you're going to repeat the process and say minus 3 plus minus 10 gives you minus 13, right? Minus 13 times this minus 5, it's going to give you plus 65 because it's minus times minus. and then minus 72 plus 65, it will give you minus 7. Minus 7 times minus 5 should give you 35. And then minus 35 plus 35 should give you 0. So you must always get 0 at the end. This tells you that the remainder, this is the remainder. The remainder must always be equal to 0, right? In this method here, so that you know that you did the method correctly. So once you are done, this expression here is your parabola. This is your parabola expression, and this is your factor, right? So your factor is x plus 5, and then your parabola, which is x squared, ax squared plus bx plus c, right? And what is your value of a? This first value, which is 2, it's your value of a. A is equals to 2, and this 13, it's your b. B is equals to minus 13, and your c is equals to minus 7. So you're just going to substitute here all these values that I just mentioned. You substitute them there. So you're going to have x plus 5, and our a is 2, so it's going to be 2x squared. Our b is minus 13, so it's minus 13x, and our c is minus 7. So that is your expression there. So now we need to factorize this parabola here. So it's going to be x plus 5, and then we factorize the parabola, so it's going to be 2x and an x there, and 1 and 7 there, so it's going to be minus and a plus. So now we factorize this expression. We know it's equals to 0, right? So we're just going to equate to 0. So it's going to be x plus 5 equals to 0, or 2x plus 1 equals to 0, or x minus 7 is equals to 0. Remember, we want to find the coordinates of b and c. So here it's going to be x equals to minus 5, or here it's going to be 2x equals to minus 1, or x equals to 7. So here we're just going to divide by 2 both sides, so it's going to be x equals to minus 1 over 2. So these are your solutions of x, right? But we want the coordinates of b and c. So for us to find the coordinates of b and c, we have to go back to our diagram, and note that we found the x-intercept to be x being equals to minus 5, and x being equals to minus 1 over 2, and x being equals to 7, right? So with these, they'll tell us where our b is and where our c is. So x being equals to minus 5, it's this point here, so we don't need it, so I'm just gonna cancel it out. And x being equals to minus 1 over 2, and x being equals to 7. X being equals to minus 1 over 2, it tells us that it's actually this point here, right? So our b would be minus 1 over 2 and 0. And then x being equals to 7, it's this point here, so our c is going to be 7 and 0. So these are our coordinates of b and c. Now we are going to do 9.2, where we are asked to find the coordinates of d and e, right? So for us to find those coordinates, we're going to go back to this equation, right, of f of x. So this is the equation, and d and e are the turning points. So basically what it means is we need to find the derivative of this f of x, right? So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? So because we want to find the coordinates of d and e, we need to derive this expression because those coordinates are turning points. So it's going to be 6x squared minus 6x minus 72, right? And then we equate the derivative to 0. So it's going to be 0 is equals to 6x squared minus 6x minus 72. And we divide by 6 both sides, and we'll have 0 is equals to x squared minus x minus 12. and then we factorize. We have x and x there. We have 6. We can't use 6 and 2 because the middle term is 1. So we're going to use 4 and 3, right? So it's going to be minus 4 and plus 3 there. And then x will be equals to minus 3, or x being equals to 4. So we have the x value of the turning points. Now we want to find the y values of the turning point. So you're going to substitute at f of x, alright, in your f of x equation. So it's going to say f of x of minus 3. So when you substitute it into the original equation, as I said, so f of x is equals to 2x cubed minus 3x squared minus 72x minus 35. So you're going to substitute in this equation here your value of x. You're going to substitute it here, here, and there, right? And you should find 100 if you substitute x being equals to minus 3. If you substitute x equals to 4, you should find minus 243, right? So these are our coordinates of the turning point. But now we need to know which one is the coordinate for D and which one is the coordinate for E. So we're just gonna go to our diagram and see which one belongs to which. So we know the x values of the turning point, x being equals to minus 3 or x being equals to 4, and the y values we found y being equals to 100 for this one, and y being equals to minus 243, right? So for D, you can see that D is actually where x is equals to minus 3, right? And then here x is equals to 4. So we can confirm now that the coordinates for D would be minus 3 and 100, and then the coordinates for E would be 4 and minus 243. So these are the coordinates of D and E. So we're going to do 9.3. 9.3 says that for which values of x will the graph be concave down? So when you talk of concave down, this is concave up, this is concave down, right? Concave up, concave down, right? So we need to note the value of x when the function does that. But we can tell from this graph which one is concave down, which one's concave up, right? So this is concave down, right? Concave down, and this is concave up. So we want to note the value of x when the function is concave down. So what defines the concavity of a cubic function is the second derivative, which is the point of inflection, right? So we need to find that second derivative of this f of x here. So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? Just going to write it properly this side here. So we have f of x being equals to 2x cubed minus 3x squared minus 72x minus 35, right? And we found the first derivative from previous question to be 6x squared minus 6x minus 72, right? And I said the point of inflection is the second derivative, so we'll find the second derivative, which is equals to 12x minus 6, right? And we have to equate the second derivative to 0, so it's going to be 12x minus 6 equals to 0. Transpose the 6 to the other side, you have 12x equals to 6, and then we find the value of x. We divide by 12, x is equals to 1 over 2, right? So we have found the value of x, of the points of inflection. So now we can interpret using our graph. So where is the graph concave down? So it's concave down here. I indicated with this color. So so it's concave down here, as I indicated with the arrows. So now we found x being equals to 1 over 2, right? Which can be somewhere here. X being equals to 1 over 2 can be somewhere here. 1 over 2. So now we need to interpret it with respect to the concave down. So concave down is before 1 over 2. So it's that direction, right? It's not going down, it's going up. So to conclude, we can say when x is less than 1 over 2, when x is less than 1 over 2, the function is concave down. So if you look up, when x is less than 1 over 2, less than 1 over 2 is that direction, right? So when x is less than 1 over 2, the function is concave down. So that is the solution, x being less than 1 over 2. Now we're going to do 9.4, where we are asked, determine the values of x such that when you multiply the f of x with its derivative, you're getting a solution that is greater or equals to 0. So make sure that your x value is less than 0. So okay, we go back to our f of x, right? This is our f of x, and we are told that when you multiply the f of x with its derivative, your solution must be greater or equal to 0, right? Yes. So where does that happen? So we're going to look at this function here, and as I said, this is f of x, and the derivative, it just tells you the flow of the function, the gradient. The derivative is the gradient. It's the gradient, right? So if you are going to start at this point and you say this arrow here, so this side of the cubic function, the gradient is increasing, right? The gradient is positive gradient, right? So if you multiply the positive gradient with this value of y, so what are the values of y from, let me just say, from this point of A going down, right? Just this portion here. The values of y are negative, right? Let me just indicate that values of y are negative. Values of y values are negative. So if you multiply this negative with this positive, you're going to get a negative, right? Positive times negative equals to negative. So that's not what we are looking for. We are looking for a situation where we multiply a positive times a positive, we get a positive. Or we multiply a negative times a negative, we get a positive, right? So so this case doesn't work. So we're going to look at the top, not here at the bottom. If we look at the top of this cubic function here, it's still increasing, right? The function is still increasing here, it's still increasing, so it's positive, and the y values are also positive here. So the y values are positive up until this point here. So you can include this point, you can include it and say that when you multiply the positive with the positive, it gives you a positive solution, which is what we are looking for, right? We're looking for a positive solution. So this is inclusive, it is part of our solution. And then let's try out here. So if you multiply, so here the gradient is decreasing, so it's negative, but the y values are positive. So this will not work because a positive times a negative gives us a negative. So this doesn't work. And then we try out here. So the gradient, or the y values rather, are negative at this point. So it's negative, 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 negative. So the y values are negative, and the gradient is decreasing. So it's negative, 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 negative. So this works because if you multiply a negative and a negative, it gives you a positive. So this works. Let's try this section of the graph. The gradient is positive here. It's increasing, 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 increasing. And then the y values are negative, 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 negative. So this won't work. Won't consider it. This one won't work. So I'm just going to cancel it out like that. And let's try out here. So the gradient is still positive, 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 positive. The y values are positive, 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 positive. So this one works. So this works, and this works, and this works. So you see, it's 3 points that work. So that's how you're going to interpret your x values, right? You should need to remember the x value of the turning point here of D. So you can simply say, if you interpret this section here, this section where I take the correct for this one here, you know the x value here, it's x being equals to minus 5. You know the x value of D, it's x being equals to minus 2, right? So you can say x must lie between minus 5 and minus 2. So this first solution of x would be correct. And then if you look at another one, which is this point here where I ticked, x at B is equals to minus 1 over 2, right? And then at E, x is equals to So before we conclude our values of x, let's first find the x values at these points. So at A, x is equals to minus 5. At D, x is equals to minus 3. At E, x is equals to 2. At E, x is equals to 4, and at B, x is equals to minus 1 over 2. Then at C, x is equals to 7. So I'm sorry with a lot of working here. So I hope you follow. So now we're going to look where I tick. So I tick here. This works for us because we want where the gradient multiplied by the y values give us a positive solution. So this works. And this works also where the gradient multiplied by the y values, they give us a positive solution. And also this one works. So where I ticked are where cases they're working, where we can find our solutions of x, right? So starting with this one, where this portion here where I ticked. So we're going to say when x lies between minus 3 and minus 5. When x lies between minus 3 and minus 5, we are getting a situation where the gradient multiplied by f of x is greater or equals to 0. Right, so this portion here is correct. And then we try out this one here also, where we can start off from B going to E. So we can say when x lies between minus 1 over 2 and 4. So this one is also correct. So if you write this or you write this, it will be correct. Or we try out this one here, and we can simply say because here at point C, x is equal to 7 and then up to infinity, right? So we can simply say when x is between 7, so I'm going to write 7 here. We're not going to say it equals to, because we don't know the infinity. So up to infinity, that's where now you get the situation where you multiply the gradient and the y values gives you a positive solution or equal to 0. So you can write either of the three solutions of x, you would be correct, right? But even if you write solutions of x that are different to this, but as long as they lie between these values that I've just given, then your answer should be correct. We're going to do question 10, where we are given a piece of cardboard with an area of 1,350 centimeters squared, is folded to form a closed rectangular box with a square base, right? The side of the square base is x centimeters and the height of the box is h centimeters, right? So this is the shape of the box, and then if you can see the base, it's x and x, so x even there and there. So now they say determine the value of, so that is the question says determine the value of x for which the volume will be a maximum. So for us to solve this problem, we need to first find the volume, right? Yes, we are given the volume, but let's find the expression of the volume. We know the volume is equals to we're going to use the base, area of base, okay. So for us to solve this problem, we need to find the volume of this shape here. But for us to find the volume, we need to use the area that we are given. We're going to use the area that we're given. Let's first try to write the equation of the volume. Volume is equals to area of base times height, right? So the area of base times height. But let's first use the area of the cardboard to find other expressions of the problem. So its area is equals to 1350, right? But what is the base? The area of the base, it's a square. So area of the base plus the area of the rectangle, right? The rectangle, which means these sides here, all four sides, because if you look at this shape, it has four sides. It has 1, 2, and this 3, and this 4 here, right? And then the base, it's 1, 2, right? So area of base, so we have 2 base, 2 area of base. So this is area plus how many sides of that are rectangular? There are 4. So you're just gonna say 4 areas that are rectangular, right? So this expression here is equals to this number here, right? To write it properly, I would say 1350 is equals to 2a of b for base plus 4a of r for rectangular, right? So 1350 is equals to 2. What is the base? Base is x, right? We were told that the base has x, and it is square, so it's a square base. So it's going to be x, which is the length times the breadth of the base, which is x, right? So, and then plus for the area of the rectangle, it's going to be the x, which is the base, this one here, and the height that is of the rectangle, which is h, right? So if you write this properly, you will have 1350 is equals to 2x squared, this portion here, plus 4xh, right? So we're going to write this expression with respect to, or in terms of x, right? With respect to x, but equating it to h. So we take this to the other side. We have 1350 minus 2x squared is equals to 4xh. Divide by 4xh, divide by 4xh. Then our h is equals to 1350 minus 2x squared over 4xh, right? So this is one part of our shape, our rectangular box, right? So which is h, and it's this one here. So this is equals to this. So now because we want the volume, the area we already found now, or the parts of the area, right? So if we were to find the area of this rectangular box using expressions, so the area of base is x squared, right? Because it's the square base, right? And then you're going to multiply it with the height of this rectangular box. So meaning your volume will be equals to x squared times h, and our h we already found here, right? So let me write this properly. So we have the volume being equals to x squared times h, but h is equals to 1350 minus 2x squared all over 4x, right? So if we substitute, we have x squared into 1350 minus 2x squared all over 4x, right? So if you simplify it, x squared into 1350 all over 4x minus 2x squared over 4x, right? So we'll have x squared into 1350 over 4x minus, so this x will go away with that one. You will remain with, and then these two will divide out with this, so you have x over 2. So this is the expression of the volume, right? So the volume is equals to that. So now you're going to multiply the x squared inside, right? So it's going to be volume is equals to 1350x squared over 4x minus x times x squared over 2, right? So the volume is equals to 1350, so the x and the x, and the x squared will divide out, so you have x over 4 minus x cubed over 2, right? And we're asked to find the value of x, right, such that this volume is to the maximum, right? So for us to do that, we need to derive this, right? But before we derive, 2 goes how many times? Here it goes twice. 2 goes how many times? Here it goes 675. So the volume will be equals to 675 over 2x minus x cubed over 2, right? So if we derive the volume with respect to x, it's going to be 675 over 2 minus 3 over 2x squared. So now we're going to equate the derivative to 0. So it's going to be 0 is equals to 675 over 2 minus 3 over 2x squared. And then we transpose the 3 over 2x squared. It's going to be 3 over 2x squared is equals to 675 over 2. And then we cross multiply, so we have 3x squared is equals to 2 times 675 over 2. Then this goes away. We remain with 3x squared is equals to 675. Right, and then we divide by 3 both sides, divide by 3, and then x squared is equal to 675 over 3, right, and then we put the square roots both sides and finding the x solution. So x is going to be equals to 15. So this is the value of x for this problem here. So now we are going to do question 11. 11.1 says that the probabilities of two events A and B are shown in the diagram. A and B are independent events. So we are given an event diagram and all the probabilities are shown. So now 11.1.1, we are asked to show that x is equals to 0.12. So one thing that we were told is that events A and B are independent, so meaning that we can use the independent formula, which is probability of A and let me write it nicely, probability of A and B is equals to probability of A times probability of B, right? So what is probability of A and B? Because we want to find the values of x, right? We want to find the value of x, hence we're doing this. So probability of A and B, looking at the diagram, it's this one here, right? It's the intersection. So it's going to be 0.28 is equals to the probability of A. Probability of A, it's this plus this 0.28. So probability of A is the 0.42 plus the 0.28, right? So you're just going to do that equals to the 0.42 plus 0.28. So that is the probability of A, and the probability of B, so it's just going to times the probability of B, it's this x plus the 0.28. So probability of B, it's equals to x plus 0.28. So it's x plus 0.28, right? So let me write this expression nicely at the side. So we have the probability of A and B equals to probability of A multiplied by probability of B, right? And we found probability of A and B is 0.28 equals to, so it's the intersection, probability of A, we just wrote it's 0.42 plus 0.28, right? And then times probability of B, it's 0.28 plus x, right? So we want to find the value of x. Remember that, so 0.28, and then when you add this, it's going to be 0.7 multiplied by 0.28 plus x, right? So you're just going to multiply out this value here. So it's going to be 0.28 equals to 0.7 times 0.28 plus, and then the 0.7 will multiply the x, so it's going to be 0.7x, and then you transpose this expression to the other side. You have 0.28 minus 0.7 times 0.28 and equals to 0.7x, right? So you divide by 0.7, divide by 0.7. So your value of x is supposed to be 0.28 minus 0.7 times 0.28 all over 0.7. So x value that you need to find is 0.12. 11.1.2, we are asked to find the value of y. So the value of y is this one here. That is not A and not B. So it's not part of the event A and B, right? So for us to find that probability or the value of y, we need to say y is equals to 1 minus, so the complement, so it's basically y is equals to complement of A union B, right? That is that. So for us to find that, we're just going to say 1 minus the union of A and B, right? What's the union of A and B? Union of A and B, it's everything inside here, right? So it's going to be 1 minus into, what is everything inside there? So it's 0.42 plus 0.28 plus, so our x, we're going to add x there, right? So y will be equals to 1 minus so 0.42 plus 0.28. So our x that we found is 0.12. So you punch this in your calculator, you should get y is equals to 0.18. So this is the value of y. We're going to find 11.1.3. We are asked to find the union of A or B, right? So the union of A or B, it's everything that is inside here, right? So how we can find that? It's P of A or B is equals to 0.42 plus 0.28 plus x, right? So 0.42 plus 0.28 plus, so our x we found to be 0.12. So if you add everything in your calculator, you need to get 0.82. So this is the solution for the union. 11.2, we are told the probability that it will rain tomorrow is 70%. If it rains, the probability that it will arrive late at the office, oh sorry, let me just repeat. The probability that it will rain tomorrow is 70%. If it rains, the probability that I will arrive at the office late is 25%. If it doesn't rain, the probability that I will arrive late at the office is 10%. Calculate the probability that I will be on time for work tomorrow. So this 70% is the probability that it will rain. I'm just going to say R, probability that it will rain. And this is the probability that it will rain, right? And I'll arrive late at the office, right? So this is the probability that it will not rain and I'll arrive late at the office, right? So I just presented each and every probability. So now we are asked to find the probability that I will be on time, I'll be early at work, right? So to find the probability that I'll be in time at work is equals to, so you're going to multiply the probability that it will rain, right? You'll multiply it with the probability that you will arrive early. How do you find early? It's because this is late, right? You'll arrive late. It will rain and you'll arrive late. So it's 25%, right? So you're going to say 100 minus 25% is equals to 75. So it's 75%. So that is the probability that you'll be early. Probability that you'll be early is 75%. So let me just write 75. So hence the probability that you'll be early, right? So it's just going to be the product and then you're going to say plus, and the probability that it will not rain. So this is the probability that it will rain, which is 70%. The probability that it will not rain is going to be 30%, right? So you're just going to subtract 100 minus 70%. So this is the probability that it will not rain, right? So you're just going to write it here, probability that it will not rain, and then you multiply the probability with this portion here, which this one here is 10% if it's not going to rain and you'll arrive late at work. So we only want the probability that it will rain and you'll arrive early at work, which is 100 minus 10, so it's going to be 90, right? So let me present everything correctly here. So probability that it will rain and you'll arrive early. So if I present this probability nicely here, so it's going to be the probability that you'll be in time is equals to the probability that it will rain multiplied by the probability that I'll be early, plus the probability that it will not rain, and multiplied by the probability that it will rain and I'll be early, right? So the probability that it will rain, as I said earlier, is going to be 70%, so it's 0.7, so you're just going to present it in decimal place, multiplied by the probability that will arrive early. Remember that the probability that you'll arrive late, it was 25%. So this portion here, it was 25%. So you're just going to write 0.75 because you arrive early. So this is for early. And then the probability that it will not rain, so it's going to be plus. Probability that it will not rain is 0.3 times the probability that it will rain and you'll arrive early, it's 0.9. So you're going to find the product here and add it with this product here, and you should get the sum of the product here and the product here to be 0.795, which in percentage form is 79.5%. So this is the probability that you'll be on time at work. So now we're going to do question 12, our last question of the paper. We're given the word winter, right? In 12.1, we are asked to find the arrangements that can be made using the letters in the word winter if the letters may not be repeated. So how many letters do we have? We have 1, 2, 3, 4, 5, 6, right? So you have 6 letters, right? And meaning that if I were to write spaces, there would be 6, right? So it's 1, 2, 3, 4, 5, 6. Yes. So you want to arrange these letters in such a way that the number of letters are not repeated. How many letters do we have? 6. So the first letter would be 6 and the second letter would be 5, right? Because we're not repeating. If we're repeating, it would be 6 again. So the third letter, it would be 4, right? And the fifth or the fourth letter rather, it will be 3 here and 2 here and 1 here. So that is how we are arranging these letters, right? Because here at number 1, we want to take 1 letter out of the 6. So we start off with 6 letters. And then here at number 2, now that we use this 1 letter, how many letters are remaining? There are 5. And then here at number 3, how many letters do we have since we used this letter and that letter here? So there are 4, right? Just like that. So basically it's 6 factorial, if you now know the factorial. So that is going to be your solution for this problem here. It's either you write 6 factorial or you write 6 times 5 times 4 times 3 times 2 times 1. You can punch this in a calculator and get your solution, or just write 6 factorial, or you write this and you'll still be correct. 12.2, how many arrangements can be made if the word starts with T and ends with a vowel if the letters may not be repeated? Cool. So we have 6 letters, 1, 2, 3, 4, 5, 6, right? And if we start with T, let's say we start with T, so I'm going to write T there, and we end with the vowel. So how many vowels does winter have? I is a vowel and E is a vowel, right? So let me write it properly. So it's winter. E is a vowel and I is a vowel. So we have 2 vowels. So V is equals to 2. So we have 2 vowels, right? So they say that it ends with a vowel. So if this is a vowel, right, how many vowels do we have? We have 2 vowels, right? Yes, we're going to choose one, but we have a total of 2. So there's 2 ways of placing vowels at the end, right? And then what remains here is since we have 6 letters and we use 2 letters used the first letter and the last letter, so we'll remain with 4 letters, right? So meaning that it's just going to be 4 factorial. It's going to be 4 factorial here. So the other letters will just be arranged in any form differently, right? So it's going to be 4, 3, 2, 1, 4 factorial. So how do we find the solution? First, the T is just going to be 1, and then this is going to be 4 factorial, and then multiplied by these 2. So the solution for 12.2 is going to be 1 times 4 factorial times 2. So this would be your solution. You can punch it in a calculator and get your answer. So your answer should be 48. So 48 is the answer of this problem here. 12.3. Determine the probability of making a new word not start with the letter T and end with a vowel. So we don't want our letter to start with T and we don't want it to end with a vowel. So let's first find the probability that it starts with a T and end with a vowel, right? The previous question, they started with a T and ended with the vowel, right? We found the solution to be 48. So it was 48. If we found the probability, so it's going to be 48 divided by the total number of letters, right? Total number of letters, it's 6 factorial, right? The arrangement of letters, by the way. So it's going to be 6 factorial, or you can write it as 48 over 6 factorial is going to give you 720, right? So the probability that the new word starts with a T and ends with the vowel is equals to 48 over 720, which should give you 0.067, right? You can just approximate it to 0.07, right? So this is the probability that your letter starts with a T and ends with the vowel. But the question says that we want a probability that your word does not start with a T and does not end with a vowel. So this is basically P of T and V complement, right? So that is the complement of T and V. So how do you find that complement? You say P of T and V complement, it's equals to 1 minus P. So let me remove this. So it's going to be 1 minus probability of T and V, right? So it's equals to 1 minus, so you're going to minus the probability that it starts with the T and ends with the V. the V just stands for vowels, right? Don't forget, not necessarily the letter, but it ends with a vowel. So it's going to be 0.07, and your answer is supposed to be 0.93. So this is the solution for 12.3. Thank you so much for watching my video. Please subscribe and comment down below. Good luck with your exams and stay tuned.